Layla Melgosa, and I'm doing mission report 5, stars, and the one I chose is the blue giant, which is right here. So the blue giant blazes with a surface temp of 20 to 50,000 degrees Celsius or more and are extremely luminous. For example, a star like our sun only has a surface temp of about 6,000 Kelvin. A blue giant star can put out 10,000 times as much energy as the sun. Astronomers categorize blue giants as type O or B stars and luminosity class 3 or class 2 bright giants, which is right here. This is an image of the blue giant. So the best known example is Rigel, the brightest star in the Orion, which is right here. This is the Rigel. Its mass is around 20 times that of the sun and gives out more light than 60,000 suns added together. Rigel's radius is about 78 and 54.26 million kilometers. The blue giants are blue because it burns hotter as it begins using the remaining hydrogen. Here is a lovely picture of the blue giant again. They evolve away from the main sequence in just a few million years as their hydrogen is consumed in heavy element star to appear near the surface of the star. So here's a diagram, and this is where the blue giants are in the main sequence. Heavy elements are dredged up to the surface by convection and mass loss due to the radiation pressure increase. And then here's another image of the blue giant. So compared to a sun-like stars, there are obvious differences in the spectrum and luminosity that they are not capable to harbor life. Sun-type G-class and smaller K-class stars are considered to be the most promising to have life in their systems. So no, these blue giants cannot hold life. And these are my references.